Today's topic is Newton's laws of motion. There are three laws. The first law is, it says a body will remain at rest or keep moving with constant velocity unless acted by a force. What does the second law says? Second law says rate of change of momentum of a body is proportional to the force applied. And has the same direction as that of the force. Right? Third law says action and reaction are equal and opposite. Now, if we see second law, we know if we apply force to any body, this changes its acceleration. And the change in acceleration, we can write this is dv by dt, which is same as this is the momentum. So what we say is, what we can see is that rate of change of momentum is proportional to the force, which is the second law. And the direction will also be same. The change in direction of velocity will be same as the force direction of force. If we see the third law, if we take a body M which is lying on the floor, it will exert a force on the floor which is equal to mg, and the floor, since floor is not moving, it will react backwards and exert a force normal to the surface, which is called normal force. And as per third law, both this force and this force will be equal and opposite, meaning thereby n will be equal to mg. In fact, if you see second law, we can derive first law from second law. How? What does the second law says? That there will be a change in momentum only if we apply force. Momentum means if mass is not changing velocity, meaning thereby velocity will change only if force is applied. So if some body's velocity is 0, it will remain at 0, means it will remain at rest. Or if it is moving with any velocity, its velocity will not change because there is no force applied, and hence there is no change in rate of momentum, and its velocity will remain constant. Similarly, we can derive third law from second law again. How? What we've seen is that if a body remains at rest, whatever force it applies downwards, a normal force is applied upwards because the body is at rest. If the body is at rest, we know that there is no net force acting on it. net force is 0. If, okay, since there is no external force, fine, okay. But we know that a body exerts a force equal to mg, but there is no net force. So what happens is there is a reaction created which neutralizes this force. And hence we can say that for every action, there is an opposite reacting force and they are equal and opposite. We have to keep one thing in mind, that whatever laws we have seen above, all Newtonian laws are applicable only if the velocity, acceleration, etc. are measured with respect to a fixed frame of reference. Called inertial frame. What does it mean? It means, for example, if there is this frame of reference xy, which is fixed with respect to ground, and if a particle is moving, then whatever distance, velocity, acceleration, whatever we measure, we are measuring with respect to ground, which is not moving, or we are measuring with respect to inertial frame, then all Newton's law will be applicable. Now suppose you are traveling in a bus, you're sitting here, and you throw a ball upwards, which comes down, or there's a fellow passenger sitting next to you. You see him at rest with respect to you, right? But the bus is moving. So what happens is, you are in a bus with this reference frame, whereas the bus is actually moving with respect to another frame. If we call this frame as O dash O. So there are two frame of references. One is this reference frame, another is this one. So if we apply, now this frame of reference is fixed with respect to ground. This is moving reference frame. If we apply any Newtonian law in this reference frame, it will not be applicable. They are applicable only if we use this reference of frame. So Newtonian laws are applicable only in case of inertial frame. And what are these frames? Which is something which is fixed with respect to ground. Or moving with a fixed velocity. Now there is a way to make Newtonian law applicable in this frame of reference by introducing a concept called pseudo force. We'll see what it is. Now let there be two reference frames as we saw earlier. One is O dash and one is O. This is inertial frame. It is fixed, it is not moving. This is moving or accelerating with respect to this. So we call it as non-inertial frame. Now, notice the motion of particle A or position of A with respect to these two frames. Suppose particle P is moving with an acceleration A. Then acceleration of particle P as seen in this frame of reference. This is S frame of reference, which is the inertial frame, and the non-inertial frame of reference we call as S dash. The acceleration of particle P with respect to S reference of frame, this red vector, is equal to the sum of these two vectors, O dash and O dash P, right? So what is O dash P? Is nothing but acceleration of P as seen by S dash, acceleration of this as seen from this frame of reference, plus this another vector which comes here, and this comes because of relative acceleration between the two frames, between this frame and this frame. There is another term which gets added, which is called, or you can say acceleration of as seen by a moving frame, or particle as seen by the moving frame is same as acceleration of particle seen from a fixed frame minus some other acceleration. What is this acceleration? This term came because of the relative acceleration between the two frames, right? So this we call as pseudo acceleration. Now, if we apply this pseudo acceleration to our non-inertial frame, then all Newtonian's law becomes applicable. Let's see with some example. Let there be a moving car. You hang a pendulum vertically. What you will see, if the car is accelerating in this direction, the pendulum will be pushed back. Right? Now, if you are a person sitting inside the van, inside the car, you will be surprised that as far as this bob is concerned, it should be at rest with respect to you. But why did it still swing back? Let's analyze this diagram. We have this bob, which was earlier vertical, but because of the moving car, it swung back, came here. Now this is tied with a string having a tension T, and let's say it makes an angle theta with the vertical. We can resolve these two components. This again is theta. This becomes T cos theta. And this is a horizontal component which becomes T sin theta. And so what we see is, this fellow will see that this component will make the bob swing at an angle theta, right? This is our mass mg. Since this becomes at rest with respect to a person sitting here in the moving frame, mg becomes equal to t cos theta, and let us say there is a fictitious force which is acting here. We call it's a pseudo force. It becomes equal to t sin theta. Now, who applied this force? Where did this force come from? We apply as far as if we see from a fixed reference frame or an initial reference frame of ground, there's a person here. He sees that only this force is being acting on this body, but whereas if we see from the reference point of view of a person inside the car, he sees that there's another force acting on the bob here, which is making it swing back. Where does this pseudo force come from? The pseudo force is coming from purely because of the fact that this frame of reference is moving, is accelerating with respect to this frame of reference. Hence, a pseudo force is generated. Now, as we have seen that with respect to this person who's sitting in a moving reference frame, he doesn't see any force being applied to this, either in this direction or in this direction. But we have already seen that there is some pseudo force being applied in this direction. So what it means is that as far as the person sitting in the non-inertial frame is concerned, he sees that this force should be equal to this. Only then he will see that there is no net force acting on the body, which means, or this we call as pseudo force, is actually equal to the force in the opposite direction. The direction of this pseudo force will be opposite to the direction of the moving body. Right? Now, there's a very interesting thing. We've seen that the person who's sitting in the moving frame, we will see this pseudo force, but as far as a person standing on the ground is concerned, he will not see this pseudo force. He will see only this force coming to picture. So, one more important thing is that pseudo force is experienced by a person in non-inertial frame. This is applicable only from the point of view of inertial frame of reference. If you are a person sitting on a fixed ground or an inertial frame, you will not see this pseudo force at all. Now, once you make pseudo force applicable in a moving frame, then Newtonian's law starts applicable. These are Newtonian's law, they become applicable.